So in this particular session, we are going to see what are the difficulties that we face while solving for the equations of motion for the constrained systems. Okay, so let's look at the simple example of a constraint system. I have here a wedge. Okay, a triangular wedge is there at I am having, and on this particular wedge there is a mass kept. Let's say the mass is m. Now I want to find out the equations of motion for this particular mass m. So this is very simple situation. Okay, so now if I want to know what is the acceleration of this particular mass in x and y direction, then obviously I have to solve the Newton's equations of motion. Okay, so now what we will do, we will find out these equations of motion. So before we do that, it is advisable always to have a reference frame. Okay, so this is our reference frame. The horizontal axis is x-axis and the vertical axis is y-axis. And let's say one additional information is that the angle that this wedge makes with the horizontal is angle theta. Okay, now we will solve this. Now if you look here, if I replace this mass m with the block with a point, okay, so to draw the free body diagram, what I will see here is that downward force is mg, obviously, and the upward force is in this way. Okay, and this is the normal force. This normal force is a constraint force. This is due to the constraint imposed by the wedge on the block. Okay, and as a result the normal force is in this way, the perpendicular to the surface. Now if I find out the components of this normal force, then of course you can see that these are alternate angles. So this is also angle theta. So this angle will be 90 minus theta, and in turn this angle will be theta. So here I have n cos theta as my upward component or vertical component, and n sin theta as horizontal component. So let's erase this particular vector. So we have two vectors, okay, two directions, n sin theta and cos theta. So now what I will do, I will write for x direction what is the acceleration or the Newton's law, Newton's equation. Okay, so mx double dot will be minus n sin theta, because n sin theta is in the opposite direction to that of the x. So, and what is my double dot? My double dot is n cos theta minus mg. So we have these two equations. Now one more thing here to note, that these two equations we cannot solve because this particular variable is extra. Apart from this x and y variables, n variable is also there. So there are three variables and two equations. You cannot solve such system. So now what to do? We can take the account the constraint here. What is the constraint here? The constraint is that the block is always on this particular surface. Okay, the block will always move on this surface as long as it is on the wedge. That means this particular constraint is written like this: y is equal to tan theta into x. Okay, this is the constraint that we have seen in the previous video, that y is equal to x tan theta is the equation of line. Okay, so if I write these three equations, okay, in such a way, okay, if I double differentiate this, then what I will get? Y double dot is x double dot tan theta. But tan theta I am not differentiating because it is constant. Now I have got three equations and three variables, so I can solve for each variable. So let's solve it. So here I will multiply second equation by sin theta and first equation by cos theta. So multiply. Now we can add these two particular equations. Let's say this is 4 equation, this is 5. So if I add these two equations, what we will get? Now let's take into account that y double dot is equal to x double dot tan theta. So substitute this in this equation. So we get, we have solved this for x double dot. Okay, so here we get mx double dot as minus mg sine theta cos theta. Okay, and then we can see x double dot is minus g sine theta cos theta. Now while solving this, we had to see that the constraint forces are there, and we had to solve for constraint forces. We have to eliminate them. First of all, we have to eliminate them, and we are not even knowing that what are the constraint forces. Okay, so this kind of difficulty is there while solving such constraint systems. Okay, now the entire goal of this particular first chapter of the Goldstein is to divert this, to divert solving for the constraint motions. Okay, so these are unnecessary things that we can divert using the Lagrangian formulation.